So my mic was muted this whole time and I was talking, which kind of sucks, but oh well. So let's get started. So I'm just going to repeat what I said to myself. So this is for the Unit 5.6 to 5.8 test on the 31st of March and the 1st of April. Um, it's just going to be units 5.6 to 5.8. It's not going to have anything from unit 0, anything from unit 4, or anything like that. She specifically said it's only going to be from 5.6 to 5.8, nothing else. She also said there's no vocab quiz, which is nice, even though that kind of does help. But it's just going to be multiple choice and standard answers questions from 5.6 to 5.8. So since there's no official review, I'm just going to like go through like, hey, this is how you do it, blah blah blah, and so on and so forth. So the first thing that's really important is the memorizing or knowing what the formulas mean and knowing how to get to the formulas. So I'm just gonna write out all the formulas right here. Y'all can like take a screenshot or whatever. I should probably just upload it. But basically what I did, I made a half pager. So we're just gonna go through each formula really because I don't really have a set review and she doesn't have a review either. It's like study on your own, which kind of sucks, but it's all right. So our first formula we're gonna look at is work. Ooh, am I writing? Ooh, ah. So it's gonna be. Can I make this cooler? That's a little cooler. So work equals force times the change in the displacement times the cosine of the angle. So the only like weird part that we see about this that we haven't really seen is the cosine, and that's pretty simple. When you're plugging into your calculator, it should, if it's, so when you read the question, if it says it's dragging, or if something's like dragging itself, or it's going the same direction, then your cosine is going to be zero since there's like not a change in degree. It's going in 1 degree like that, so the angle is zero. And when you put cosine zero into your calculator, you should get one. But if the cosine's like 4.5 point like 45 degrees, you put cosine 45. I think that'll give you like a decimal. I don't really know. I'm gonna do it right now. Cosine 45. Yeah, it would give you like 0.707. So like that's kind of important when you're looking at work. So make sure to look for the cosine and look for any like keywords that help you to find the cosine. If it's 90 degrees, it should equal zero. I am mostly certain about that. Yeah, 90 degrees equals zero, and that's really it. It's force, pretty self-explanatory. It's newtons, so the total newtons that's being put onto the object, and then change in displacement is just where it has changed. Um, so this unit is a little weird. I like this unit, but the reason I say it's weird is because can it go like that? No, that doesn't work. Is because you have to use multiple equations to find the answer. Like it could give us the initial velocity, the final velocity, the change in time, the mass, the change in displacement, everything. But we don't. It doesn't give us force, and we're trying to find work. And force is pretty important to find work. So what we would be doing is we would be finding the formula for force, which is force equals mass times acceleration. So I guess you could say there's some unit like 0 unit 4 stuff, but like, and since we get the mass and acceleration, we gotta find acceleration. So acceleration equals um v of f minus v of I squared. I am pretty sure I don't memorize it. Yeah, squared over 2 delta d. So that's how you find acceleration. So once you find acceleration, you can find force. Then once you find force, you can find the work that's being done. So it really this unit, it's not confusing in my opinion as other units, but it does require you to know some formulas. But you have the formula sheet, so you should be fine. And it's like a puzzle piece. You're just trying to put the puzzle pieces together and use the formulas that we've learned, and that's on the formula sheet to answer the question. So most questions, I think almost all questions, require you to do at least like 2 equations to solve the answer, maybe 3 sometimes. But like that's our first equation we've gone through. So work equals force times change in distance times the cosine of the angle. That's our first equation. So we're gonna just go papa. Now blah blah. Second equation we're gonna look at is power equals work over change in time. To get work, like we figured out, is work equals force times change in displacement times cosine of the angle. So that's that over delta t equals power. And work is measured joules, I'm pretty sure. Yeah, work is measured in joules. So power's unit should be J over S. J/S is the power unit because work is J, time is S, J over S. It's pretty all right formula. It's all right. It's not as confusing as the other ones. Just gonna erase that. It's taking forever. Can I just go? Nope, cannot go like that. All right, next equation. So this is where we're getting into like kinetic energy and potential energy and Wnet. So kinetic energy, what it is so kinetic energy. This is a formula for kinetic energy. Kinetic energy equals 1/2, 1/2 times m times v squared. I just put the multiplication symbol because I know just to like separate the values a little bit, it helps me. So this is mass, like of course that's gonna be in kg. This is gonna be in m/s, and then half is gonna be 0.5. So that's really how you find kinetic energy. And the units for kinetic energy are, let me remember, it is joules, I'm pretty sure. Yeah, it's joules. So that's how you figure it out. So you should find the mass, the velocity, and then with that you can find the kinetic energy that's inside of the object, or the object has. Pretty self-explanatory. I'm just gonna go over the formulas because I really don't have a review to go off of. And blah 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 blah. Ah, taking forever. And so the next thing we're gonna do is next formula we're looking at is Wnet. So Wnet, I work net. I call it Wnet. It has a nice ring to it. Is a change in kinetic energy, and that equals basically K of K of F minus K of I. Um, Most likely certain that is the correct formula to find that. So Wnet really equals the final kinetic energy minus the initial kinetic energy. That's an I. And to find the final initial kinetic energy would be using this formula. K of F equals 1/2 times mass times V of F squared. And then to find K, oh gosh, Ke of initial, we would do the same formula, but instead of F, we would do the initial velocity squared. That's how you get the two Ke's. And then with that, you can find the W net. Wow, my writing sucks. That's really it. When you ask you for W net, let me see if there's anything else I need to add. No, that's really it, I think, for that formula. Give me 1 second. Where's my pen? I lost my pen. So Wnet basically just means the total work done on the system. Now that it's just like the net force. Yeah, I think that's correct. I think that's what Miss Kelly says. It's a net force. Kind of like the speed force. So I've been watching a lot of Flash lately. Speed force, work force. Yeah. Anyway, moving on. I am getting distracted. So the next equation we have is elastic spring. The potential energy for an elastic spring. To me, this is a little confusing. I'm not gonna lie. Because we haven't really done a work with this. I'm gonna look for a question later on, and I'll send it. So basically, it's PES, which stands for spring. Potential energy of a spring is equal to 1/1/2 times K times X squared. This looks a lot like a kinetic energy formula, but the K and X are different. So what the K means, the K is for spring, the constant of the spring. So that should be in uh, N/M, I'm pretty sure. Let me look at the PowerPoint. If it loads. So y'all took the ACT today. Hope y'all did really great. I expect good grades from everybody. Especially you, Renai. I'm talking specifically. I know you'll watch this, Renai. I know exactly you will. Maybe you will. Maybe you won't. Where's that thing formula? Here we go. Boop 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 boop. I feel like a teacher. Like dragging something from across. Okay. Anyway. So we haven't really learned this formula. I'm trying to explain it as best as I can understand it. So I'm just gonna put these side by side. What do I do? So PE, we have that 1/2 that K, which is in newtons over meters, which is a spring constant, which is based the toughness of the spring. It's how strong it is. And then X is spring stretch compressed, so that's gonna be an M. And I'm trying to look for an equation with it, with the using this, but it's just like any other equation. You find your givens, you find your unknowns, you find what you need from the formula, and try to solve it like that. And that's the best I can explain. I'm sorry I can't explain it too well. We haven't really gone over it, so I don't really expect it to be on the test too much. Maybe one question, but I don't really expect that to be on the test, really. But that's like the only equation that I really don't understand. Because the other equations, okay, they make sense. I don't really understand that since she hasn't gone over it. Or maybe I wasn't paying attention. Either or. Anyways, we're going to stop talking about me. We're going to move on to gravitational. Potential energy of gravitational, which equals M times PIG. M times G, I almost said P. Whoop, times H. So this is the mass. I forgot I had the little g. This is mass. I cannot write. That is 9.8, which stands for the gravitational force, but it is positive for this unit, not like negative 9.8 meters per second. And then H stands for height, which is going to be in meters. So you're going to find the mass, you're going to find the height, and then you got 9.8 already. That's already a given. And that's how you find the potential energy of gravitational. It's not that hard. Just got to know these formulas like that and know what each unit stands for. There's nothing really I can explain to that. It's just the only thing that I think that's gonna kill us is the rounding. I suck at rounding, which kind of does suck a lot. Anyways, moving on to the TME formulas. So TME stands for, if I believe I am correct, TME stands for the sum of kinetic energy and potential energy of a system. So with that, it says on the PowerPoint, we can automatically see TME equals KE plus PE. It's basically the total amount of energy with kinetic and potential. I can assume that because on the PowerPoint it says the sum. Sum is adding things together. Come on, ACT, SAT prep. Y'all know this. Come on. So the formulas we're going to be looking at, well, if TME is a closed circuit, like no energy is escaping, like let's say, I can put this into example for people to understand this. So let's say I have a hose, right? And it goes from one bucket to the other bucket. And it goes from here to here. Well, if it's closed and nothing is escaping, theoretically, when this bucket empties, if this bucket is full, then it empties, and they're the same size, then this bucket should be full with the same amount of water, right? But if it's open, like if there's a crack right here, say there was a crack right there and water was escaping, then this might have this much water left when this is empty. It's just closed just means nothing is escaping. That's what it means when it says closed on the thing. I think that's a pretty good way to explain it. I don't really got any other. I thought that was really smart of me saying that. Papa MG will be so proud. And y'all are smart anyway. Y'all probably already knew that. I didn't have to embarrass myself and waste time. So with that being said, we can, since uh, KEI, the initial kinetic energy plus the initial potential energy should equal the final kinetic energy plus, oh, I can't speak, the final initial energy. Those should equal each other. Whether this is like 5 and this is like 4 and this is like 1, then this should be 2. I don't know why I said that, because that equals 6 and that equals 6 and 6 equals 6. Y'all know what I mean, I guess. I don't really know what I'm saying anymore. It's 11:25. I'm running good on time, baby. I already went through TME. TME, also the last equation we're going to look at is TME. Initial should equal, it does equal, not should, equal the final value of TME final. I do not know what I'm saying. That's really all of it. Those are all the formulas we're going to be looking at. So I keep a little formula sheet. I like writing out the formulas. I like memorizing the formulas. To me, it just helps me go faster, helps me understand the concepts. It just really helps. Um, Here's an example of what I mean by closed circuit. So bang, see, like Miss Kelly said, TME is always going to say the same value, and they're always going to be equal to each other. Not equal to each other, but added together, they'll equal TME. They'll equal the same, what's it call it? They'll equal the same amount at the end of the day. There's Snorlax, pretty cute. And that's really all I have for this Zoom. I didn't really have a lot planned since it's literally just a couple equations. It's just like not even a full unit. If you have any questions, try to reach out as much as you can. I might not respond because I might be at work or might be busy with some other things. So feel free to contact Amira. Amira, if you're watching this, well, you are my you're gonna be contacted a lot. That's really all I have for y'all. I just wish y'all luck on your on the test and on the ACT. Hope y'all did great. Good skill, Mr. Bonanno. Speaking of teachers, we got Mr. Clarity right here. Always got to remind him of Mr. Clarity. Anyways, that's really all I have. I'm just blabbering right now. So, have any questions? Try to reach out to me or Mira. You can put this off for cast hours, and I am trying to think of anything else to say. I don't really have anything else to say. I think that is it I have for y'all. Yeah, just try to do some stuff, get some good rest. Y'all had a long day, so I didn't want this to be too hard, too confusing from the people that just took the ACT. And this is just all I'm gonna say. So y'all have a great night. I love you all. Kisses. Mwah mwah. Bye.